Hello everyone, here we are, starting a new chapter in our lives. So this chapter, chapter 8, kind of has a lot of different topics thrown in, like 3 or 4 different topics. But the first 3 sections are all about sequences and summation notation. This section is kind of an introduction to that topic, and then the next couple sections will get more specific about certain types of sequences and how they behave and things like that. So let's see, what is a sequence? A sequence, it's kind of like, it's kind of like a function. Sequence is like a function. You know, we've seen before, like, say, f of x equals, and then some kind of command, you know, I want to input x, and it'll output, let's say this one's 2x minus 3, or something like that. But I guess the difference between a function and a sequence is a function you can pretty much put any x value in you want. I mean, as long as it's part of the domain. You can put whole numbers, you can put negative whole numbers, you can put 0, you can put fractions. You know, you can pretty much put whatever you want in for an x value. But with the sequence, you can only put whole numbers in. It's like a function whose domain is whole numbers. So you'll only be inputting whole numbers, so which are, you know, like the counting numbers, 1, 2, 3, 4, 5, you know, on and on and on. So those are the only values you're going to put in. And usually a sequence, you don't write f of x. I think it's just to show that it's a sequence, you kind of use a different notation. Sequence looks like, so instead of f of x, you're going to use an a. So a kind of takes the place of f, and then a subscript of n kind of takes the place of your variable. So a sub n is like f of x. It's kind of like a function. It kind of tells you a little formula for what values you're going to get out when you substitute certain ones in. So if I was trying to make it similar to this previous one here, f of x, the function 2x minus 3, you'd see it as 2n minus 3 instead. So that's all of a sudden a sequence. And you're only allowed to input n equals 1, n equals 2, n equals 3, n equals 4, and on and on. You can't put negative numbers in for n. You can't put 0. You can't put fractions. Things like that. But let's see. Let's just jump right into one. Actually, this first example is pretty similar to the one I just wrote, huh? It says that the sequence that we're interested in here has, they call that, the general term, a sub n, which is like the function, a sub n equals 2n plus 5. And they want us to find the first 4 terms, it says here. Which means you're just going to input n equals 1, n equals 2, and n equals 3, and n equals 4. That's pretty much all that means. Replace n with 1, then with 2, then with 3, then with 4. Just whatever, you know, this time they said the first 4 terms, but depending on how many terms they want, you're going to stop at that value. In this case, it's 4. So I'm going to say a, and this time I'm going to write a subscript of 1 because I'm trying to find the first term where n equals 1. And then I'll find the second one, the third one, the fourth one, and so on and so forth. So that means I'm going to take this kind of function-looking thing over here and write 2n plus 5, but n is going to be replaced with 1, and then 2 for the second one, and then 3 for the third one, and then 4 for the fourth one. So whatever your subscript happens to be, the little number that's here where the n is usually, a sub n, I have a sub 1, a sub 2, a sub 3, a sub 4. So I'll put in a 1, and then I'll put a 2, and a 3, and a 4, and I'll see what I get. The first one, it's 2 plus 5, so I'll get a 7. That means the first term of this sequence is a 7. And then the second one, 2 times 2 is 4, plus 5 makes 9. Then you have 2 times 3, which is 6, plus 5 makes 11. The last one is 4 times 2 is 8, plus 5 is 13. So this sequence, this is our answer. These are the first 4 terms of the sequence, 7, 9, 11, and 13. And then this next one should be pretty similar. It says, write out the first 4 terms of the sequence whose nth term, or general term, is a sub n equals 3n plus 2. So it looks like, excuse me, I'm trying to find the first through the 4th term. So I'll find a sub 1, a sub 2, a sub 3, a sub 4. And that just involves me taking this general term that I've just circled and replacing the n with 1, and then I'll replace it with 2 here, and then I'll replace it with 3 here, and and I'll replace it with 4 here. And whatever I get, those are the first 4 terms of the sequence. I'm replacing with 1 because that's the subscript of the first term, and then 2 because that's the second term, 3 because that's the third term, and 4 because that's the fourth term. And then I'll simplify. That's 3 plus 2, which is 5. There's our first term. We have 6 plus 2, that's 8. That's our second term. 9 plus 2 is 11. That's our third term. 12 plus 2 is 14. There's our fourth term. So the first 4 terms of the sequence are 5, 8, 11, and 14. Those are our guys. So it's kind of interesting. Yeah, like I said, it's kind of like a function, except there's a starting value to an input and a kind of a logical succession from there. You know, you put in a 1, then you put in a 2, then you put in a 3, and then a 4, and then you can imagine from there you put in a 5 and a 6 if they wanted more than 4 terms. Whereas a function, there's not really a first value to substitute in. It doesn't make sense because you can put in anything you want. Positive, negative, fraction, you know, anything you want. This next one looks like a complicated guy. But we'll still kind of do the same thing. Excuse me, they want the first 4 terms, so I'm going to replace first n with 1. In this case, the general term here has more than one place to put an n. So I'm just going to replace both of them with 1 here. So it's negative 1 to the 1 power over 2 to the 1 power plus 1. And the 1 I'm mentioning is just because the subscript of the first term is 1. This is our first term. And then our second term. It's going to look almost exactly the same. All the blue stuff I just wrote is going to be the same. But the red is going to be now a 2, because I want a sub 2, negative 1. Now it's to the second power, because n is changing to 2 now, over 2 to the second power plus 1. Let's see. I'm replacing n with 2. There was an n here and an n here. They're both going to be changed. And, you know, I'll simplify each of these as we go. It's kind of nice to just set them all up, though, I think. A3 is the same thing, but those both exponents are now 3's. Where are we? Here we go. 3, 3. And then the fourth one, they only asked for 4 terms, so I'm going to stop after the fourth one. It'll be negative 1 to the 4th over 2 to the 4th plus 1. So let me see here. 4, 4. Okay. So we got it all set up. Now I just need to simplify each one of these. Negative 1 to the 1 power is negative 1 over 2 to the 1 power is 2 plus 1. Looks like we got negative 1/3 for our first term. And then the second term, you have negative 1 to the second power. That's negative 1 times negative 1, so it's positive 1 over 2 to the second power is 4 plus 1 makes 5. Looks like 1/5 is our second term. And then our third term, we have negative 1 to the third power. That's negative 1 times negative 1 times negative 1, which makes negative 1. Pretty much anytime you have a negative 1 to an odd power, it's going to be negative 1. But negative 1 to even power is going to be positive 1. Over 2 to the third power, which is 8, plus 1. Looks like the third term is going to be negative 1/9. And then the fourth term, which is the last term we care about, because they only asked for 4 terms, is going to be negative 1 to the 4th. That's an even power, so we get a positive 1 out of that. Over 2 to the 4th, which is 16 plus 1, makes 1/17. So looks like our first 4 terms are negative 1/3, positive 1/5, negative 1/9, and positive 1/17. Not too bad. Now let's see, let's try this one. Write out the first 4 terms of this sequence whose nth term or general term is negative 1 to the n times n plus 3. Alright. Same kind of thing. I want the first 4 terms. So I'll just kind of set them up here. A1, A2, A3, A4. And now for the first one, since the subscript is 1, I'm going to replace both n's with 1. So it'll look like negative 1 to the 1 power, and then times 1 plus 3. And I'll simplify that. The next guy, n is 2, because it's the second term, so it'll be negative 1 to the second power times 2 plus 3. And then the third one, let's see here, is negative 1 to the third power times 3 plus 3, because n is 3 this time. Okay, here we go. 3, 3, 3. And then the last one, well, the last one we care about, the negative 1 has a 4th power, oops, and we want it to be n plus 3, so we want 4 plus 3 this time, in the second parentheses. So negative 1 to the 4th times 4 plus 3, alright. And then we'll just simplify each of these until we can't simplify anymore. The very top one, A1, that's negative 1 to the 1, that's just negative 1 times 1 plus 3 is 4. So it's negative 1 times 4, which is negative 4. There's the first term of our sequence. The second guy, A2, you have -1 to the second power, that's +1, times 2 plus 3 is 5. So you got 1 times 5, which is just 5. The third term of the sequence, -1 to the third is -1 times 3 plus 3 is 6. So -6 is your third term. And the fourth term, -1 to the fourth is +1 times 4 plus 3 is 7. So that makes 7 total for the fourth term. So there are our first 4 terms of the sequence. It's -4 and then 5 and then -6 and then 7. Not too bad, huh? And once you get the hang of it, it's not so bad. It's pretty similar to functions. But this next objective, it kind of gives us what they call a recursive sequence. Recursive. Did I already write that here? Yeah. Recursion formulas, they call them, but these are called recursive sequences. So the difference is, the previous types of sequences we were dealing with just now, when you have the general term, you're replacing n with 1 for the first term, replacing n with 2 for the second term, n with 3 for the third term, n with 4, and these terms don't depend on each other. You know what I mean? So it's not like, I didn't really need to know the first term was -1/3 in order to find out that the second term was 1/5. And I didn't need to know either of those terms to find out that the third term was -1/9, and so on and so forth. So those ones, each term is not dependent on the previous terms, but with recursive sequences they are. It's like pretty much to find any term of the sequence, you take the previous one and do something to it. So this one, for example, in this part 2a, it says a1 is 3. So we already know our first term. They've given it to us. The first term, a1, is 3. So then the second term, I should be able to find using this recursive formula they give me. So they say a sub n is 2, and then a subscript n minus 1. So in this case, I can actually replace both n's with 2, because it's a sub 2, which means the right side is going to look like 2, a subscript, n is 2 minus 1 plus 5. So that means, let's see, a2 is 2 times a, and then the subscript, you can simplify that. 2 minus 1 is 1 plus 5. So really what this means is I'm taking 2, multiplying it by a1, which is the previous term, and then we're adding 5. So that's how we find the second term. Multiply the first term by 2, because that's part of the formula, then add 5. Like I said, because that's part of the formula. So I can say, okay, this is 2 times a sub 1, they told us was 3, so I'm just going to bring him down. 2 times 3 plus 5, that's 6 plus 5, which is 11. There's our second term. And we'll do a similar thing for the third term. They said they want 4 of them, so we've got to keep going here. The third one. In the third term, we can find a similar way, but now I'm replacing n with 3. So I've got a subscript 3 is going to be, like I said, according to the general term, it's going to be 2, and then the subscript for a is n minus 1. So it's a, and then n, which is 3 in this case, minus 1 plus 5. And I can simplify that. That subscript is 3 minus 1, which is 2. So that means we're taking the previous term, because a2 is the previous term, which was 11. So I'm actually replacing this guy here. Because remember, that's what we found in the previous part. So we're going to multiply, yeah, kind of the same thing as we did before. Multiply the previous term by 2, because that's part of the formula, then add 5. That's what we're doing now. So it'll be 2 times the previous term, a2, we found to be 11. 2 times 11 is 22, plus 5 is 27. So there's the third term of the sequence. And then I think you kind of get the hang of this now. The fourth term is going to be 2 times the previous one plus 5. I just bring down the previous term. The previous term we just found was 27, so he's going to go right here. And then we'll just simplify that. 2 times 27 is 54, plus 5 is 59. So there are the first 4 terms of this sequence. It's a lot harder. You're not just inputting n equals 1, n equals 2, n equals 3, n equals 4. You're kind of inputting the previous one into the next one. So it was 3, and then we involved 3 in finding the second one, which was 11. Then we had to involve 11 in finding the third one, which was 27. We had to involve him in finding the fourth one, which was 59. But then we're all done. So I think at this point we're probably feeling okay about that, or more okay than we were. So I think this next one we can do a little bit quicker, I think. The first term is 4, that's what they told us. The second term will be, okay, using this formula, I'm just going to grab it and bring it down. It's 2 times the previous term plus 3. That's what, just think of that a sub n minus 1 as the previous term. So that's really what that means, if you ever see that. So whatever the previous term was, in this case, they told us the first term was 4, so the second term should involve that guy. 2 times 4 plus 3. See, 2 times 4 is 8 plus 3 is 11. So there's our second term. The third term is similar. I'm just taking 2, multiplying it by the previous term, and then adding 3. In this case, the previous term was 11, so I'll be inputting that guy in there. 2 times 11 plus 3, that's 22 plus 3, which is 25. Okay, and then the fourth term, which is the last one we care about, because that's all they wanted, A4, is 2 times the previous term plus 3. The previous one was 25. So I'll input that here. Let's see, 2 times 25 is 50, plus 3 is 53. And I think we're doing good, yeah. Those are our first 4 terms. 4, let's see. They already gave that one to us, so we didn't have to work too hard for that one. 4, and then 11, and then 25, and then 53. Not too bad. So okay, then the next objective here is we're going to do something similar. We're just finding the first 4 terms, or the first however many terms of each sequence, but they're involving a new thing we haven't learned about yet, factorial notation. So maybe we should talk about that a little bit over here. So let's see, the definition of factorial. It looks weird, but if you take a whole number, we'll call it n, and write an exclamation point after it, that actually means something mathematically. It means that whole number, whatever it is, n, multiplied by 1 less than that, multiplied by 1 less than that, and then keep multiplying until you get to 1. And that, I don't know, that probably doesn't make a whole lot of sense because n is general right now, because it's just, this is the definition. But I think if we do a couple examples, it'll make more sense. Let's try, let's see, for example, what if they wanted us to find 3 factorial? So 3 factorial, that means 3, and then multiplied by all the smaller whole numbers until you get to 1. So it goes 3 times 2 times 1, and that's it. Once you get to 1, you stop. But 3 times 2 is 6, times 1 is still 6. So the answer is 6 for that guy. And then maybe a bigger number. How about, I don't know, 6 factorial. That means you take that number 6 and multiply it by all the smaller whole numbers. 6, 5, 4, 3, 2, and 1. And you multiply all those together. So let's see, 6 times 5, that's 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. 720 times 1 is still 720. So you can tell these factorials, they get pretty big pretty quickly if you let the value of n get larger and larger. But that's the idea behind factorial. And they're involved in some sequences, and we'll actually see factorial a couple sections from now again. So it's good to have seen it now. But notice this example 3a, it kind of sounds similar to one we've done before. Just find the first 4 terms. So we go, what's a1, what's a2, what's a3, and then what's a4, that's the last one they want. But now there's a factorial involved in the general term. So now that we know what factorial is, it shouldn't be so bad. I'm going to replace n with 1 first. So it'll be 1 squared over 1 factorial. And then I'm going to do the same thing but with 2 for the second term. 2 squared over 2 factorial. 3 squared over 3 factorial for the third term. And then 4 squared over 4 factorial for the fourth term. And then we'll just simplify. Let's see, the first one, 1 squared is 1. 1 factorial is actually just 1, and that's because factorial means multiply that number by all the smaller numbers up to 1. But, there's nothing smaller than 1, so it's just 1 by himself. So 1 over 1, which is 1. The second term is going to be 2 squared, which is 4, over 2 times all the smaller whole numbers until you get to 1. But all there is 1 below 2. It looks like 4 over 2, which is 2. For the second term. And then the third term, you're squaring 3, that'll give me 9. The denominator 3 factorial is, we saw that actually in the example we did. 3 times 2 times 1 is 6. So it's 9/6, which simplifies to 3 halves. And the fourth one, which is the last one we care about, 4 squared is 16 over 4 factorial, that's 4 times 3 times 2 times 1. 16 over, let's see, what is that, 12 times 2 is 24? Yeah, 24. And I think that reduces to 2/3. There we go. So I think once you get the hang of factorial, these aren't so bad. It's just kind of a brand new concept that maybe we're not used to. But let's try this other one. This one has a factorial as well. They want the first 4 terms again, so I'm going to kind of set it up. Replace n with 1 first, so it's 20 over 1 plus 1 factorial, and then 20 over 2 plus 1 factorial for the second term. And then 20 over 3 plus 1 factorial for the third term. And then the fourth term is 20 over 4 plus 1 factorial. Alright, and then notice that the number that's in the parentheses with 1, whatever n was, it's in parentheses, so we have to actually add first before we find the factorial. And the first one is 1 plus 1, which is 2. So it comes down to 2 factorial, which, okay, if you write that out, that's just 2 times 1, which is still 2. So it's 20 over 2, which is 10 for the first term. And then we'll move on to the second term. Like I said, we have to add those two numbers in the parentheses together before we calculate the factorial. 2 plus 1 is 3 factorial, which we calculated in that example above. When we first learned about factorials, that's 3 times 2 times 1, which is 6. So second term, we have 20 over 6, which reduces to 10 thirds. And then the third term, 20 over 3 plus 1 is 4 factorial, which I feel like we just calculated earlier, but oh well. That's 4 times 3 times 2 times 1, which is 24. So 20 over 24, and I think that reduces to 5/6. Okay, and then the last one we care about, 20 over, I have to add those numbers together before I factorial it. 4 plus 1 is 5 factorial. We'll have 20 over 5 times 4 times 3 times 2 times 1. That's 20 over 120, I believe. Is that right? Let's see. 6 times 1, 21. Yeah, okay. And that reduces to 1/6. Yeah, alright, there we go. So you kind of get the hang of it once you see, I don't know. Yeah, once you see the factorial. Oh, and I think something got lost in translation here. I'm sorry, let me see. I think it's right on your paper. It's correct on your paper. Shoot, what did it say? I think it looked like this. 6 and then n equals 1, 4n? I think that's what it said. Something like this. This is just trying to explain what the summation notation means. So let's see. This is... Let me just kind of point out all the parts. This weird symbol, this looks like kind of like an E. I don't know. Does that look like an E? Just this kind of choppy symbol, the big choppy symbol. This means sum. Or remember, sum means add. So when you see this symbol, you know you're going to be adding things together. And the things you're adding together are the terms of this sequence. This is a general term of a sequence. General, yeah, term of a sequence. So, you know, this one, for example, my sequence a sub n would be 4n. Whatever is directly to the right of that weird symbol, this guy right here. And then, let's see, the other numbers in there, let me try to differentiate it with a different color. The number that's on the bottom, in this case, n equals 1, this is your starting term. So in this case, we're going to be starting with the first term, because I said start with the first term. And the number at the top of the summation symbol is going to be your ending term. So this, really what this says, this little symbol here with all the numbers, it says we're going to add the first through 6th terms of the sequence a sub n equals 4n. So we have to, that's kind of the only difference between the summation notation that we're learning right now as opposed to the just the sequences we've been dealing with so far, is that the summation notation, it still tells you to find a certain number of terms of the sequence, but in the end you're not just listing those terms, you're going to add them all together, and whatever you get as a sum is going to be your total answer. So in this first example, let's see, this is saying you want to start at the third term and end at the 5th term. So we're going to find the third through 5th terms of the sequence whose general term is in the parentheses there, 2 to the n power minus 6, and then we'll add them together. That's really what this whole, I don't know, this whole weird symbol says. I mean, that means the same thing as these words that I've written here. Oops. Let's see. Yeah, all this is kind of like the English version of the weird symbols. First I'll find the terms themselves. I can skip over the first two terms because they said start at the third one. So I'm just going to find a sub 3, and then I'll find a sub 4 and a sub 5, because that's where they said to stop. And all I'm doing is replacing n equals 3, n equals 4, n equals 5 in this. So it'll be 2 to the 3 minus 6, and then 2 to the 4th minus 6, and 2 to the 5th minus 6. Whatever the subscript happens to be, that'll be the exponent on 2. So 3rd power, 4th power, 5th power. There we go. And then I'll simplify those. Let's see. 2 to the 3rd is 8 minus 6 is 2. There's the first guy. 2 to the 4th is 16 minus 6. That's 10. And then the last one that we care about, 2 to the 5th power is 32 minus 6. That's 26. So that I would be done if this was just a regular sequence, but what they want us to do is add these together. So our answer is going to be 2 plus 10 plus 26. Whatever that is, that's our total answer. Let's see, that's 12 and 26, that's 38, I believe. So I guess, and that's a difference between your answers for a sequence and your answers for summation notation. In a sequence, you might have lots of answers because they might want the first 4 terms, so you have 4 answers. Or the first 6 terms, so they have, you want 6 answers. But these ones, you're adding them all together in the end. So you really only need that very final total, that sum that you added together. Hopefully that makes sense. And then let's see, this one looks like we're going to add the first 5 terms of the sequence from the first, add the first, because that was the starting point. They said start at the first through 5th, because that's the ending point, it looks like, terms of the sequence. And you notice this time they're using a different variable. You're using k. So if you want, you could just write k if you're okay with that. No pun intended. Or you can actually just change the k's to n, because I think at this point we're used to n. I kind of like that better. So either one, I think this makes me feel more comfortable, because that's what we've been dealing with this whole time. I'll find a sub 1, replace a with 1, replace a with 2, all the way to 5. And whatever we get for all those terms, once I simplify each one separately, we'll add them all together. So yeah, the general term is n times n plus 4. So these guys will all look like that. Something times something plus 4. Something times something plus 4. I'll try to just draw the little skeleton of it just to make my life easier. Okay, and then where the n's or the k's, whatever you want to call them, were, I'll first be putting a 1 in there. So it'll be n times n plus 4. And then it's a 2. 2 times 2 plus 4. And then 3 times 3 plus 4. 4 times 4 plus 4, 5 times 5 plus 4. And I'll simplify each one of those. This one, the top one is 1 times 1 plus 4 is 5. So it looks like it's 5. The second one is 2 times 2 plus 4 is 6. That's 12. The third one is 3 times 3 plus 4 is 7. So 3 times 7, that's 21. The fourth one, 4 times 4 plus 4 is 8. So 4 times 8, that's 32. And then 5 times 5 plus 4 is 9. That's 45. So we got all the terms of the sequence. Now we take all those guys and add them together. So the answer is going to be, when I add those guys together, 5 plus 12 plus 21. 12 plus 21 plus, what else? 32 and 45. Yeah, and don't feel bad if you use a calculator. There's nothing wrong with that. Let's see. What's that going to give us? We got... Let's see, these ones together, I think this is 38 total, is that right? Yeah, 38 total, this is 77. Those guys together make 115, I believe. I think I added those right. Well, if I didn't add them right, you know what I'm trying to do here. So that one, their total answer is 115, no need to even talk about anything else besides that. Let's see, this next one's kind of weird because this one says you're going to add up the first 4 terms of this sequence. A sub n or a sub k, whatever you want to call it, is just 3. There's no n or k involved. That means no matter what n is, the value of the term is going to be 3. No matter what n is, it could be 1, it could be 2, it could be 3, on and on. The term is always 3, which kind of weirds me out, but what are you going to do? So if they're saying they want us to find the first 4 terms and add them together. A1, A2, A3, A4. But these terms don't depend on n, so they're all 3. That's what this is saying. Because the general term here is just 3 no matter what. There's no n involved. So they're all 3. I just need to add those together. 3 plus 3 plus 3 plus 3 is 12. So really those are the easiest problems. When the general term has no variable, like the last one, then that's the easiest problem. It's just, I kind of second guess myself and think I'm doing it wrong sometimes. But this last one of this type, now they're starting at the second term because k equals 2 is the start, all the way up to the 7th term. 2nd, 3rd, 4th, 5th, 6th, 7th. And this one looks like it's one we might have seen before. We found the general, or we were looking at the general term earlier. I'm just raising -1 to the n power, whatever n is. These all are starting as -1 to a power. It looks like the first thing I'm putting in is a 2 because that's the first subscript, and then a 3, and then a 4, and then a 5, and then a 6, and then a 7. So I remember we talked about this a little earlier, that -1 to any even power is +1. So every other one of these is a +1. And -1 to any odd power is a -1. So all the other guys that we haven't talked about yet are -1s. Okay, and then we're supposed to add these all together. So we add these. But I think, you know what, these are all going to cancel each other out. Add, it's 1 plus -1 plus 1 plus -1 plus 1 plus -1. I think they're going to cancel each other out, because here these guys add up to 0, these add up to 0, these add up to 0. So your answer for this is going to be 0, which is kind of interesting. Those last two are kind of, I don't know, too strange for me to feel like I did it right, I guess. Let's see, and then these last couple problems, I actually included 4 of them with no examples, so don't worry about these bottom 2. I think you get the hang of it from doing these top 2. This is now, we're going backwards. What we want to do is write it as the sum of something, where are we starting, where are we ending, and what's the general term. So we've got to find out, for this sequence here, what's the general term, and then what's, what are we ending at, ending value of n, and this is our starting value of n. Value of n. Alright, so I think it looks like what's changing here is the base. It's always, something's always being raised to the 2nd power, so it looks like it's n, whatever n is, to the 2nd power. Because if you input a 1 in there, you get 1 to the 2nd power, you put a 2 in there, you get a 2 to the 2nd power, on and on and on. And it looks like the first thing you're inputting in there is a 1, because that's the first term, and the very last term you're inputting a 9. So I think that would be what's going on there. You're adding the 1st through the 9th term, and the general term is n squared, because it would look like 1 squared plus 2 squared plus 3 squared plus 4 squared, on and on. And I think this one should go a similar way, but this one has a different general term. Because this one, it looks like the base of the exponential is always 2. 2 to some power. And the first one's a 1 power, the second one's a 2nd power, 3rd power. So it looks like n is your power. Because I put a 1 in, I'm starting at 1. I got 2 to the 1, and then 2 to the 2nd, 2 to the 3rd, all the way to the 11th. So I think the 11th power is the last power that we need there. Alright, and I think that does it. So I'll see you in the next section. It should be good. Like I said, this section is very general. It's just talking about all kinds of sequences and the summation notation. But the next section, it kind of gets more in depth on a certain kind of sequence, and we'll have formulas for how to add, find the summation of those types of sequences. It'll be a nice looking formula.